Hi guys, this is Mr. Ivan again. Thank you for all your feedback about the videos. Some of you very funny, try asking me to make it like more like a celebrity with some intro, and so by popular request, if you like this video, do remember to subscribe by pressing the bell button. Is there a bell button? I myself don't even know. Okay, so to cut to the chase, like in my IG post, I say that there's 3 skills of integration that you have to know very well. If you don't know these 3 skills, don't bother going for exam, okay, because definitely you will not be able to do any integration questions, okay. And one of the most important is called making the integral the subject. Alright, now in this question 1a, they ask you to differentiate something. So don't confuse differentiation with integration. Know your differentiation technique and integration technique very well. Alright, so for 1a, in the method I should write below. Okay, so 1a. Alright, remember your notation, differentiate with there's no y there, so we have to use d dx ln x. Okay, and this is equals to, and after differentiation, many students finish differentiation already, totally forget that differentiation you need to have quotient rule. Okay, so I will have this. Remember, this is my u, and then this is my v. If at this moment you do not know your integration, you ought to go and do not know your product quotient rule, you ought to go and revise it up about it. Okay, so okay, so it's v du dx, so we keep x. Alright, differentiate ln x minus keep ln x, okay, and then differentiate x, which is just 1 over x squared. Okay, so I will have, you have 1 minus ln x over x squared. Alright, this is the first part where they ask you to differentiate. Okay, so the second part, hence find this. Okay, so this is the integral that they want you to know. So remember, the first concept is no product rule or quotient rule in integration. No, there isn't any. Okay, there's no product rule, no quotient rule in integration. So when you see a quotient and a product like that, you must immediately either think of using the differentiated value, okay, or number 2, if you think of integrate f prime x over fx. Alright, f prime x over fx is equals to ln fx. Alright, this one I will talk about it in a separate video. Okay, I will tag the link in the description below. Okay, so now in this question, this one they are looking for x squared over, integrate of ln x squared over x squared. Now you would not be able to find this answer directly. Okay, so you need an indirect way of getting the answer. So the thing with most students is they think that, oh, when the question asks them something like that, they are going to start the question with, oh, integrate ln x squared over x squared dx equals to, and you can't start the question like that. Okay, now tell me why they ask you to differentiate the first part. It's because to get the second part right, you have to make use of the first part. Okay, so when the first part says that if you differentiate, the first part says that when you differentiate this guy, you will get this guy. Now what does integration mean? It means that if I integrate 1 minus ln x over x squared dx, what will I get? I will get ln x over x, okay, with a plus c behind. Alright, so that's the opposite, understanding the opposite of integration. If you differentiate ln x over x, you get this. So when you integrate the result, you get back ln x over x. Okay, now once you have this already, then recall what is your question. So the question is integrate ln x squared over x squared. Yeah, this is your question. So you got to break it out slowly, go and find. Alright, so this fraction numerator is bigger than the denominator, so I can say that, oh, this is 1 over x minus ln x over x squared dx equals to ln x over x plus c. Okay, then you slowly realize that my answer is somewhat looks like him. Okay, so that is why this technique is called making the integral the subject. Okay, so I can say that, oh, this is integrate 1 over x dx minus integrate of ln x over x square dx equals to ln x over x plus c. Alright, the plus c is just an arbitrary constant, so you can easily change your c to something else. Okay, so who do we want to make the subject? We want to make him as the subject. Alright, so I'll bring him to the right. So I will have integrate 1 over x is equals to, okay, integrate 1 over x is equals to ln x. Alright, then minus ln x over x, okay, plus d is equals to integrate ln x over x square dx. Basically what did I do? I brought this to the right side because this is negative here, so I brought this to the right side. I bring him over, okay. C, when I bring over, I don't want to write minus c, I can write as plus d, and because I integrate this already, there's also an arbitrary constant inside, so the new arbitrary constant is d. Alright, so now I write back the whole thing. Okay, integrate ln x over x square dx is equals to ln x minus ln x over x plus d. Okay, but what do I want? My objective I want is ln x square, which is here. Okay, then now think again. What is ln x square equals to? Okay, the first few things is once you see a power in a log, you have to think of bringing it down. Ln x, 2 ln x. Okay, so what do I need? I need to make sure that it is a 2 ln x inside. Okay, so if I times 2 on the left side, okay, I must also times 2 to the right side. Okay, so I will have integrate ln x square over x square dx equals to 2. You can just leave it like that, ln x minus ln x over x plus d. Okay, and that is your answer. Okay, so remember, if an integration for the first part they ask you to differentiate something, never ever think that they ask you to differentiate for fun. Okay, it will definitely be helpful in the second part of the question, regardless of whether they told you to use there's a hence or not. Okay, so making this in the integral the subject is a important skill that you have to know how to do. Try it out yourself, make sure you got the right answer. Okay, so as Bruce Lee says, I scared not the man who knows 10,000 kicks, but I'm scared of the man who practiced the kick 10,000 times. Alright, there you go.